Welcome to Ask and Learn.
Alright guys, to solve this problem, we first need to use the psychrometric chart to determine the enthalpy H1, specific volume V1 and absolute humidity W1 by using the given temperature, that is T1, that is equal to 10 degrees centigrades, and we've got phi 1 is equal to 70%. So we find H1, that is 23.5 kilojoules per kg, and we've got V1 is equal to 0.81 cubic meters per kg. Then we have W1 is equal to 0.00532. Next, we can take the specific volume V1 and calculate the mass flow rate using the given volume flow rate, that is V1 is equal to 26 cubic meters per minute, and M1 is equal to capital V1 divided by small v1, so it's 26 by 1.0.81 is equal to 32.10 kgs per minute. So we will also need the enthalpy and H2 and absolute humidity. We know that there is no condensation in the heating process, so absolute humidity remains the same, that is W2 is equal to W1. We can use that and the temperature T2, that is 18 degrees centigrades, to determine the enthalpy H2. So it comes out to be 131.6 kilojoules per kg. Now for the enthalpy H3 and the absolute humidity W3, we will need the temperature T3, which is equal to 25 degrees centigrades, and the relative humidity phi 3 is equal to 45%. So H3 is equal to 47.8 kilojoules per kg, whereas W3 is equal to 0.00888. Now, for part A, the heat transfer rate can now be calculated as Q is equal to M1 into H2 minus H1. So we put the values over here, that is 32.10 multiplied by 31.6 minus 23.5, and the answer is 260.01 kilojoules per minute. Now for part B, from the conservation of mass, we can calculate the mass flow rates, that is mw is equal to m1 multiplied by w3 minus w2. So 32.10 multiplied by 0.00888 minus 0.00532, and that is equal to 0.114 kgs per minute. So, guys, these are the answers to this question. I hope you have easily understood all the calculations and the formulas. Thank you very much.